Welcome to AsyncCode. Hi everyone. Hope you're doing great. Make sure to like and subscribe to stay tuned for more videos. This code provides an empirical demonstration of a multi-layer perceptrons, MLP, versatility by showing that it can accurately approximate a nonlinear function, in this case, the sine function. Y equals sin, x. Using PyTorch, we generate input data across a range and train a simple MLP with one hidden layer and ReLU activation to predict the sine values. Despite its simplicity, the MLP learns the nonlinear pattern through iterative optimization, and the resulting predictions closely match the true sine curve. This showcases the MLP's power as a universal function approximator capable of modeling complex, nonlinear relationships in data. First, we import the PyTorch library, which provides tools to work with HDF5 files. Import required libraries. Set random seed for reproducibility. Generate input data, 100 points evenly spaced between -2 pi and 2 pi. Compute the corresponding true output using the sine function. Convert the number py arrays to PyTorch tensors and reshape them to be column vectors. Define a simple feed-forward neural network, MLP. The network will have one hidden layer with 50 neurons and ReLU activation. Pass input through the network layers. Instantiate the model. Define a loss function. Mean squared error is good for regression problems. Use the atom optimizer for efficient gradient descent. Train the model over 1000 iterations. Forward pass. Compute the model's prediction for x. Compute the mean squared error between prediction and true values. Zero the gradients before backpropagation. Backward pass. Compute gradients. Update the model weights. Every 100 epochs, print the current loss. After training, use the model to predict the sine curve. Plot the true sine curve and the model's approximation. Now run our code. That's it for today. Like, comment, and subscribe to stay updated.